this video, we're going to talk about representing functions as graphs. First, the vocabulary. A function consists of a set called the domain containing numbers called inputs and a set called the range containing numbers called outputs. The domain is a set of all inputs of a function, and the range is a set of all outputs of a function. When we talk about relations or functions, we can represent them graphically, in a table, in a mapping, or as a set of ordered pairs. We can also represent them verbally. For example, the output is 5 less than twice the input. As an equation, we can say y equals 2x minus 5. Using a table, we can plug in 0 to get -5, 1 to get -3, 2 to get -1, and 3 to get +1, and we can also represent that as a graph. Example 1. Graph the function y equals 1/2 x with a domain of 0, 2, 4, 6, and 8. First step on our table, our domain, recall, is our x value, so that's just 0, 2, 4, 6, and 8. Half of 0 is 0, half of 2 is 1, half of 4 is 2, half of 6 is 3, and half of 8 is 4. We fill in our y's, and then we just plot our points. So we have 0, 0, 2 and 1, 4 and 2, 6 and 3, and 8 and 4, and we have plotted our graph, and we're done. Example 2, SAT scores. The table shows the average scores S on the mathematics section of the Scholastic Aptitude Test, SAT, in the United States from 1997 to 2003 as a function of the time t in years since 1997. In the table, 0 corresponds to the year 1997, 1 corresponds to 1998, and so on. Graph the function. So we're going to graph 0 and 511. So 0 and 511 would fall here in the middle. Then we have 1 and 512. So that's also in the middle. We have 2 and 511. So approximately there. We have 3 and 514. 4 and 514. 5 and 516. And then 6 and 519. And we were done graphing. Example 3. Write a rule for the function represented by the graph. Identify the domain and the range. So if we look at our graph, we can see we have a y-intercept of 1. And if we go, to use our slope to get from point to point, we can see we go up 2 over 1, up 2 over 1, up 2 over 1. So our equation just becomes y equals 2x plus 1. So we just fill in the table. So we have 0 and 1, 1 and 3, 2 and 5, and then we have 3 and 7. So now we just write our domain. We'll use D. You can just write that as 0, 1, 2, and 3. In range, we'll use R. That'll be 1, 3, 5, and 7. And we are done. Example 4, guitar sales. The graph shows guitar sales in millions of dollars for a chain of music stores for the period 1999 to 2005. Identify the independent variable. Describe how sales changed over the period and how you would expect sales in 2006 to compare to 2005. So our independent variable, let's talk about both. The independent variable and the dependent variable. So independent variable is just my years. My dependent is my sales. Dependence. Okay, so just like in the last example, it appears that there is a constant change. So it looks like our y-intercept is 0.4, and we're going up by 0.1 every year. So 0.1 million in sales. Every year we go up 0.1 million. And we have one more to go up, 0.1. So our equation is just y equals 0.1 x plus 0.4. Now, we're talking about years since 1999. So we do, and we were asked about what do we expect the sales to be in 2006. So 2006 minus 1999 should give me 7. So all I have to do is plug in 7. So we get 0.1 times 7 plus 0.4 is 1.1 million. So based on the slope, it should be 0.1 million more than 2005, and we are done solving this problem.